So our next speaker is Xiao Liu, and he will be presenting intrinsic arousal dynamics alternately support sensory encoding and hippocampal ripples. Thank you very much, Xiao.
Yeah, thanks. And first, I have nothing to disclose. And my group, I think, is interested in finding out what's like the neural basis underlying those resonance state fMRI fluctuation or the correlations. And the one particular thing we are interested in is like the global signal in the resonance state fMRI. If you went to like the Monday session, I think people still debating whether you want to regress it out from your resonance state analysis. But a few years back, we have already showed those like the GBO signal, we call it the GBO signal, actually take the highly organized pattern as like the propagating waves goes from between the sensory motor region and those high order like the cognitive network like the DMN. If you map out the direction of the propagation, is really like it shows us like the cortical gradient of the hierarchy. And we have the same thing for the monkey ECOG data, shows us very slow like the propagating waves. Since then, we have been thinking about what a function those like the global like the waves may serve. Yeah, but if you think about the pattern, I think it is really analogs to just like the information flow in those artificial neural networks, right? Because if you do that, you know those large-scale model, I think the only way you can really optimize those model, you have to use those like the back propagation and then adjust the arrows layer by layer. So those like the cross-hierarchical propagating could be very essential for like learning and memory. And that's a reason why I think later we just check the large-scale neuronal recording data from the Allen Institute, because one of the reasons is those recording has a lot of the recordings from the hippocampus, which is like the key, like the brain region for the memory. We do see those similar like the global signal in those like the resonance states, like the spiking data. Then they are highly organized as a spiking cascade, we call it. It's like the sequential like the activation among different neuronal groups, mostly between two groups of neurons. And it's also coupled by those arousal fluctuation indicated by the pupil size. But most importantly, it really couples the change of those like the ripple rates, as well as those like we have like the new paper published is also related to those like the hippocampal replay. Yeah. And that's the reason why we hypothesize those like the global brain activity may just represent like the offline process linking the memory and the arousal system could be very important for the like the memory consolidation. But later we think maybe its relevance may go beyond the resonance states, because people know those like the resonance states, those like the ongoing activity actually accounts for those like the trial-to-trial variability, not only in the neural response, as also the behavior, like the response variability. And also in the like the animal fields, a lot of study regarding how those like the pupil size change, how those locomotion actually affect those like the sensory like the response. And because of that, we think is that possible this like the highly organized global signal would affect those like the online sensory processing. But the first question we need to like answer is why do we still see those like the cascade dynamics during the like the stimulated states? Yeah, because previously we only use those like the spontaneous session from the Allen Institute, because that's more like the rest state for the human. But they actually have a lot of like the stimulated session. One of them, they just present those like the visual stimulus like every 250 milliseconds to the animal. That's more like the continuous visual stimulation. Then we got the data, we do everything the same. But if you look at those like the spiking activities, just we even cannot tell the difference between them. But if you just zoom in and look at those like the visual neuron to the average, indeed, during those like the stimulated condition, you do have the phase locked, like the response. But compared to those like the cascades dynamics, it's just too small to see. And then we just define like the one-dimensional index. We call it like the state index to quantify those cascade dynamics. Basically, we got like the two groups of the neuron at the two ends of this cascade makes a difference. Then we believe it's related to the like the arousal, like the status. If you like do a distribution of this state index, the shows distribution better described by like the two Gaussian process. Then we found like a threshold based on that, cut to like the time into more like the we call the stationary low arousal and stationary high arousal states. Then we want to know how those like the visual processing relate to those like the cascade dynamic quantified by the like the state index. We want to go beyond that because a lot of the previous study focus on the like the response amplitudes, but we want to do better, so we use like the machine learning model. We just try to predict the stimulus ID based on the like those spiking data. And we assume if we got like a higher accuracy, it just means the brain like the encoding those like the visual stimulus better. Then we do that, then if we compare, as I said, we can, for those like the cascade phase, we can cut it into like the stationary high and the low, like the states. If you compare these two, you see a very systematic increase. Yeah, the encoding accuracy is much higher for the like the stationary high state. And also, we do a continuous like the correlation between those accuracy and the state indexes. Actually show a very, very like the striking like the linear correlation and very reproducible across the animals. Yeah. Then we want to say, okay, indeed, those visual coding variabilities are actually driven by those like the cascade dynamics. So we just average those like the visual coding like across those cascades cycle. It's very closely follow this like the change of this like the state index. Yeah, but then we also look at like the hippocampal repose. We still say, even though the repose mostly you see during the resting states or like the sleep states, but actually it's also there during the like the continuous stimulation. But if you look at its modulation, it's just the opposite to those like the sensory coding. Yeah. Okay, then we have some like the sensitivity analysis. We take out one region, see how those prediction, like the accuracy change. And then we also do the prediction using the regional signal. But the basic idea is quite reproducible across different regions. But those early visual region and the thalamus has a higher like the prediction power, yeah. Then we look at like so far, what I talk about is always like the stationary state, where the animal just stay there, don't move. But as long as like those mouse start to run, those cascades, like the dynamic just are gone. Yeah, basically everything shifted towards this higher arousal state. If you look at this, like the state index distribution is largely overlap with this stationary high state. And if you compare those like the accuracy, it's just similar to those like the stationary high, but significantly higher than those the stationary states. Yeah, then we further look at those dynamics at the transition to the locomotion. We figured out actually those neural, like the state index, they couple with those like the decoding accuracy quite well, but they are decoupled from those like the pupil size and the locomotion at the transition. They actually start early, like the 2 seconds early before that. Yeah, so how to explain this finding? I think there is a classical like a theory talk about like the function of the sleeve. And basically, I think a whisking is more like the encoding mode. The slow wave sleep is more like the consolidation phase. But one of the key players is like the cholinergic tone. Yeah. For this cascade, we have no data to link them to the cholinergic system. But for those like the G-boats, like the waves, we actually have the evidence a lot of the For example, those like the nucleus basalis region shows very specific deactivation at those G-bold waves. And also, I think one of the authors in their group, they deactivate this NB region. It can suppress those G-bold signal. Because of that, our interpretation of this result is basically those like the low frequency global activity just alternate the brain between two function modes, like which is more optimized for the like the encoding and the consolidation or the memory retrieval, like respectively. But that's not on the like the hours time scale. It's actually on the seconds time scale, and this may explain those like the well-known like phenomenon, like the human performance. It's actually optimized at those like the intermediate, like the arousal level. That's because this level people probably get the best balance between the like the encoding and the like the retrieving. To summarize, I think we see those like the cascade structure previously we saw at rest. It's actually persists on the continuous visual stimulation. It modulates both visual coding and the ripple rates, but in opposite way. And we think that may represent a mechanism brain like the alternate between two different like the function modes, optimized for the external sensory information processing and the internal like the memory process. And also the cascade diminished during the like a locomotion, but it's unlikely because of the locomotion. It's more because the locomotion associated with like the higher arousal states, because we see those neural and the encoding change even before the like a locomotion starts. Okay, also compared with the previous observation, I think it's more like the sensory responses depend on the arousal, depend on those like local pre-stimulus, like the ongoing brain activity. Here we show, okay, it's probably more like the depend on the highly structured global brain activity of arousal relevance. And the most important thing is not independent from the memory process. It's actually closely linked to those like the memory process. Yeah. If you want to know more details, we have like about ICAV like a preprint, and also welcome to talk to me during the post session. Yeah, thank you.
So we're right on time, but we might have time for a very quick question from the audience if there is one. Did you want to ask your question?
Yeah, maybe could you just comment on what your machine learning model is that you used and what features are used?
Yeah, we use like the support vector machine, but we also tried a few models, like the deep learning type of the model. I don't think this makes any difference. Yeah, the feature, we don't really extract any feature. We just put all of the neural spiking data in. Yeah, thanks.
Okay. If you've got any other questions, please come and see Zhao at the poster session later on today. Thank you very much.
Thanks.